Okay, so this brings us on to the new learning for today. So we're trying to find, in today's lesson, a missing angle rather than a missing side. So in this question here, it's telling me to find the size of angle BAC. So from B to A to C, so it's this angle here. So I can still label the question exactly the same as I've done before. In fact, there's no need for me to change what it's already labelled as. So the angle involved is called A, so that's here. Then we've got B and C as the other vertices, and then the side opposite A is going to be lowercase a, side opposite B is lowercase b, and the side opposite C is lowercase c. So the problem here is that if I use this formula here, if I substitute everything in, it's not going to give me cos A straight away. Okay, so in fact, let's just do that. So that would be 12 squared is equal to 10.5 squared plus 15 squared minus 2 times 10.5 times by 15 times by cos A. So it's actually the angle here that I'm looking for rather than everything else. And there are two different ways that you could do this. The first way would just simply be to work everything else out that you can here, and then to simplify afterwards. So for example, that would be 12 squared is 144, 10.5 squared is 110.25, 15 squared is 225, and then minus 2, we can work out just this part here, 2 times by 10.5 times by 15, and that bit would give me 315, and it's multiplying cos of A. Then we just have an equation, and we can solve to find out what A is. So I could work this bit out here. So 110.25 add 225 would be 335.25. And then what a lot of people do, which you can't actually do here, is to then do 335.25, take away 315. You can't do that because the 315 is multiplying the cos of A. It's a little bit, we're using BIDMAS here, so you must multiply first and then you would do the subtraction. So it's 315 times by cos of A, and then you would subtract the answer from 335.25. So the way that you would solve this is to see that, well, this is positive here, so you've got 335.25, and then you're subtracting 315 times by cos of A. So you could subtract 335.25 from both sides. So if we were to do that, then we would get minus 191.25 is equal to, remember this is still negative here, minus 315 times by cos of A. And then because we're trying to find A, it's first of all, we're finding the cosine of A, and then we're multiplying it by minus 315. So divide both sides by minus 315. That will give you 0.6071428, blah, blah, blah. Your calculator will remember that. And then this is the cosine of A, not A, so you could do the inverse of cosine. So A is equal to our cos of our answer there before. Remember, you can just use the answer button on your calculator. You don't have to write it all out like this. And then that would give you that A is equal to 52.6168 and on degrees. To one decimal place, that's just going to be 52.6 degrees. So as I said, this was just one way that you could solve this, and there's quite a few places here where this could go wrong. So first of all, obviously you've got to substitute everything in here. Something may go wrong at that point there. Also, the next part where it may go wrong is that people try to combine all of the numbers here together, which you can't. You can only add these two numbers here. And remember that this is 315 is multiplying cos A. Another part is once you subtract 335.25 from both sides, it will leave you with a negative number here. And then, of course, when you're solving the trigonometric equation at the bottom, that causes people some problems as well. So some people use this method, some people don't quite like this method. I use a mixture of both, so it's useful to know how both of them work anyway. So I'm just going to show you the other one as well. Okay, so if you're going to do the other method, one thing that you can do is to realise that actually it would be much handier if you're trying to find out what the angle is here, is if you just had something like cos A equals something, or A equals something. So if you made A the subject or cos of A the subject. So what you could do is actually just to rearrange this formula straight away here. And then you can see that if we want just cos of A on its own, first of all, we can see that it's being multiplied by minus 2bc, and then after that it's being taken away from b squared plus c squared. So first of all, we can get rid of the b squared and the c squared. You could do this all together, or you could do it one by one. So if I did it one, I could subtract b squared from both sides, so I'll have a squared minus b squared equals c squared minus 2bc cos of A, and then I could get rid of the c squared, so it's positive c squared, so I could take that away. So a squared minus b squared minus c squared is equal to minus 2bc cos of A. So remember, we want cos of A as a subject, so it's being multiplied here by minus 2bc, so I'll divide both sides by minus 2bc. So a squared minus b squared minus c squared, all divided by minus 2bc, is equal to cos of A. And some people will just remember it like this, but most of the time in the textbook you'll see that we don't really like to have a negative at the denominator here. So if it's being divided by a negative, that's just going to mean that everything that's negative in the numerator is going to become positive, everything that's positive is going to become negative, or you could imagine everything here is being divided by minus 1. So we could say that a squared is going to become negative, so it'd be minus a squared. Minus b squared divided by minus 1 is going to become plus b squared. And then minus c squared divided by minus 1 is going to become plus c squared. We've divided by the negative here, so we're left with 2bc, which is now positive, and that's still equal to cos of A. Then we could say that we normally don't like to start off with a negative here, so we could have b squared plus c squared minus a squared, all divided by 2bc, is equal to cos of A. And this is the way that you would normally see it written in a textbook. So cos of A is equal to b squared plus c squared minus a squared all over 2bc. Some people would choose to memorize this off by heart so that you can use it straight away if you're looking for the angle using a cosine rule, and other people decide to just rearrange it straight away from the start. So just write this down, just remember this, and then rearrange it every time you need it. And then other people would just substitute into the cosine rule as you've done it originally, and then just rearrange that equation afterwards. It's completely up to you how you would prefer to do it. So on these two examples, I'm going to just use what we've just used there. We could just use that to find these, and this will be slightly quicker because there'll be no rearranging of the equation needed. There'll just be one step at the very end where we just want to find A and not cos of A. So if we do it on the first question here, then we can label it as we did before. So this is capital A, so this is lowercase a for this side. This side vertex here is B, so the opposite side here is B. This vertex here is C, so opposite that is going to be C here. So if I put all of this down, it's going to be cos of A. We don't know what that vertex or that angle A is there, so I'm just going to leave that as it is, equals B squared, so 10.5 squared, plus C squared, which is 15 squared, minus A squared, which is 12 squared, all over 2 times B times by C. Now I could literally type all of the right hand side into my calculator, and that would give me 17 over 28 as a fraction, or if you wanted to write it as a decimal, it would be 0.6071, on and on and on. And remember, this is cos of A and not A itself. So if I want to find out what A is, I'll have to use inverse of cos. So A is equal to arc cos. Let's use the fraction, so 17 over 28. Remember, I could have equally put the decimal here, it doesn't really matter. And that will give me the same answer as I had before, 52.6168, on and on and on. So to one decimal place, it would be 52.6, exactly the same as what we did before. let's just do the same thing on this example here. So this is a completely fresh question. I'm going to use this formula up here at the top. So it's already labelled for us. So let's say, for example, that the question is asking us to find this angle here at the top, so the A here. Remember, you may have to change it so that this the angle at B might be asked for, or the angle at C might be asked for, and it's completely up to you how you adapt that. So on this question then, we could say that cos of A, that's this angle here at the top. Oh, let's just label everything first. So this side would be lowercase a, this side opposite the B would be lowercase b, and this side opposite the angle C will be lowercase c. So that's equal to 8 squared plus 7 squared minus 9 squared all over 2 times 8 times 7. Type that into my calculator, and that will give me an answer of 2/7. I could, if I wanted to, so that's approximately 0.2857, on and on and on. And remember that that is cos of A, so I just want A itself. So I need to do the inverse of cos, so arc cos of 2/7, or the decimal equivalent, depending on what you want to use. And that would give me 73, A is equal to 73.3984, on and on and on. So let's say I want it to one decimal place, so that would be 73.4 degrees. Okay, so now it's your turn. Okay, so what you will notice about these questions is that only an angle has been labelled, and that's what you're looking for. So for the first question, I want you to find angle A here. On the second question, angle B here. On the third question, angle C here. And on the fourth question, angle D here. So make sure that you're writing these down and labelling the triangles correctly. Okay, so pause the video now and have a go at these questions, please. Okay, apologies if you watched the original video and you got these answers and you were confused. These answers are actually wrong. Thank you for those people who pointed it out to me and left a comment on Show My Homework. I think I made a slight error with copying and pasting, or I've done something else. I don't actually know how it's possible to get those answers. So the correct answer should be A equals 36.3 degrees. B is equal to 82.8 degrees. C is equal to 123.7 degrees. And D is equal to 132.0 degrees, all to one decimal place. So if you did get these answers over on this side, these are the wrong answers, and these answers here are right. I've kept those up just in case some people were a little bit confused. Apologies for that. I know it's really confusing when that happens and it's a completely new subject. So again, if anything like that happens again, then please let me know and show my homework and I will change it for you. Thank you very much.